Hello everyone, and this is the third lecture in the course Digital Image Processing of Remote Sensing Data. And in this particular topic, we are going to discuss why digital image processing is important. In the previous lecture, we have discussed about how data can be acquired, and especially about the remote sensing data, and also we have learned how images of different part of electromagnetic spectrum using different types of sensors, active, passive, and scanning, non-scanning, various types of these scanning and non-scanning sensors we have discussed. So now let's discuss about why digital image processing important. Basically, if we start looking the definition of digital image processing, the digital image processing focuses or the purpose of digital image processing of two folds. One is the improvement of pictorial information for human interpretation. Remember that the ultimate aim of satellite remote sensing data is to make the interpretation on the data so that we can make inferences. Later in this course, I will be showing some examples how an image, satellite image, we can make interpretations after processing, and then how inferences can be made. And processing of image data for storage, transmission, and representation for autonomous machine perception. Another aim is nowadays, which is really a hot topic, is that how we can involve machines. Machines means basically here computers, so that everything or most of the things becomes automatic. And you might have heard about this Google car and others. So their image processing at very high speed is going on. So ultimately identify the objects and accordingly receive the instructions and drive a car. And there are some, say image processing, digital image processing is a kind of trade-off. So you lose some information, but you get some other information. So there are some argument about where image processing ends, the fields such as image analysis and computer vision start. But this is one way of looking the things. If we look the little history about digital image processing, what we find that somewhere early in 1920s, one of the first applications of digital imaging was in the newspaper industry. The photographs which were taken were of not that quality which printers of newspapers wanted. So they wanted some enhancement so that image improves. And one photograph here is given, and that kind of quality, that too in black and white, was available for newspaper industry somewhere in 1920s. And this is Barth Lane cable picture transmission service. The example here given, images were transferred by submarine cable between London and Newark, and there were no wireless technology, and pictures were coded for cable transfer and reconstructed at the receiving end on a telegraph printer. This cable for the transmission, and nowadays we use jipping and unjipping, and there are some other methods also for better transmission, but most of the transmissions now is happening wireless or through satellites, and if long distances are involved, or towers and other things. So the technology has changed, but this is what we had in somewhere in 1920s. There later on, mid to late 1920s, the improvements to Barth Lane system resulted in higher quality images and improved digital images. Image you can see here. At that time only 15, that means the 16 shades of colors were there, 0 is also there, and new reproduction processes based on photographic techniques and were developed, increased number of tones in reproduced images. Tones means here the number of shades available for printing. So instead of just simple black and white, that is binary, you move to up to at least 16. And then later on, these are the moon pictures taken by Ranger 7 probe minutes before the landing. And that time, a lot of improvements have taken place as compared to 1920s, and improvements in computer technology and the onset of space race led to surge of work in digital image processing, and that too the transmission started. Before that, the wireless transmission. In 1964, computer used to improve the quality of images of moon taken by Ranger 7 probe. So that stage came very quickly, and such techniques were used in other space missions, including Apollo landings. And of course, in 1972, later on, we had our Landsat MSS, and lot of new image processing techniques, or it became digital image processing became very easy, and still it is improving. But in somewhere in 80s or till today, the use of digital image processing techniques has exploded. As I have just mentioned, they are now used for all kinds of tasks in all kinds of areas. So there are different fields where digital image processing are happening. Even nowadays in our own small smart mobiles, we can improve a little bit our images taken by the mobile camera and can transmit as well. But when we handle large images acquired by the satellite sensors, then the more scientific methods have to be evolved. And the main purpose here, image enhancement or restoration of the image, the quality of image, so that it looks soothing to the viewer and we get much details in the image rather than just few gray shades. Artistic effects should be there. So we can now by bringing digital image processing and some fancy filtering techniques and other things, we can bring artistic effects. Much use of digital image processing is now in medical visualization, whether it is ultrasound image or X-ray, or there are various imaging systems in medical sciences are being used. There also image processing plays very important role. Industrial inspections where thermal cameras and other cameras are used, and such images are also improved. Law enforcement, especially in night time, the images are acquired by CCTVs and others. Those too can be improved so that the person can be detected. Human computer interfaces, this is another field where things are happening a lot, that most of the things we want that computer should do it, and then less influence or less interventions by human, and so that the task becomes faster if these are the routine tasks. Some examples are given here about image enhancement. One of the most common uses of digital image techniques to improve quality, remove noise, etc. And two examples are here, rather three examples. The first one, as you can see, in a raw X-ray image, this was the situation, but when it was enhanced, now you get much better detail, and interpretation by doctors can be much easier. Second is about a micrograph photograph taken for some electronic circuits. As you can see that there were a lot of noise. Once the noise, the speckle were removed, the image becomes much easier to understand. Similarly, this is an oblique photograph taken by some aircraft, and this is what you can see, that a lot of now improvement in the image and better interpretations can be made. Similarly, examples, the best example, because in 1990s the Hubble telescope was launched and could take images of very distinct objects, but somehow because of problems in optics, they were out of focus, and the problem is that you cannot bring and repair. So now it was a challenge for the digital image processing, and it was done. And as you can see here, this is Hubble telescope. These are the images which it was acquiring. After image processing, these images were much improved and interpretation could be made. So however, on incorrect mirror, which later on people realize, which was on board of Hubble's images or Hubble's telescope, created problem. And as I mentioned, that image processing techniques could fix this problem to some extent. And there are examples from remote sensing fields. One example we have already seen, many more are here. The digital image processing techniques to use extensively to improve satellite images. One of the major reasons, because between satellite and Earth there is an atmosphere. And generally atmosphere deteriorates the quality of an image. It brings the distortions in the image. And therefore once the image quality is not up to the mark, then image interpretations can be also affected. So in order to improve our image interpretation analysis, the first thing is to improve our image by employing digital image processing techniques. And here because ultimately the images may go for pattern recognitions or terrain classifications and other things. So for that purpose and the image processing is required. Maybe our images might be coming from meteorological satellites or geostationary satellites, which will be used directly in meteorology for forecasting or predictions. There also the improvements might be required, so that can be done there. And sometimes when we acquire nighttime images, maybe of like night lights of the world, the example is here, then again digital image processing can be done. This is useful to know quickly the global inventory of human settlements, and not hard to imagine the kind of analysis that might be done by using the data. People have employed these images in case of some disaster, like suppose an earthquake has occurred. So naturally the power supply gets affected. So if you compare an image before the earthquake and after the earthquake, immediately you know which are the affected areas. So in that way, a lot of usefulness is there about such images. There are various stages, various steps, processing steps of digital image processing, and these are though in this flow chart they are given, but you know that there is not any starting point from that point of view. But if we start the problem domain from here, image acquisition is the first thing, and then image enhancement. Some image enhancements, some improvements in the quality is done immediately once the image has been acquired by the satellite. We might be going for image restoration. These things we will see in much detail. Morphological processing, and for further enhancement, then segmentations in the image, object recognitions might be in image classification, then representation and description in this one. We also go for image compression. One of the topics in this course we are having on image compression, and color image processing is nowadays very much required. That is also done. So if you start from here, you may end up like this, but as I have mentioned, that directly one can go from image enhancement to object recognition, means for classification. It depends for the purpose, for which application you are going to employ remote sensing images. Accordingly, you would use different image processing techniques. And now, as I have already mentioned, that digital image processing is a trade-off. You lose something, you gain something. So one has to be careful while doing the image processing, that what ultimate aim is, and accordingly different image processing techniques should be employed. Now these are the like image acquisition. We have already discussed in the previous lecture that the satellite sends that transmit the data towards the Earth, and the examples are given here. The satellites are there, they are transmitting data towards the Earth. You should have a antenna, a tracking antenna for polar orbiting satellites, and then there has to be a system, recording system, means hard disk, software and other things, and then you can make the archive of such images. And as you know that this all happens because of in daytime, because of the sun, and there are the energy has to reach to the surface and then go back to the satellite. So these are the things. This is the first step, is the image acquisition, where if once the image is acquired, then real image processing starts. So this is the first step in that one. Then image enhancement, as the example is given here, and this is the raw image. After some enhancement, you can see the improvement in the quality of image for the interpretation. Image restoration. Sometimes what happens that a satellite has acquired an image, there might be some problem on the sensors, and like here one example is shown about the different lines which are appearing, and these are the artifacts. These have to be removed if we want to use this image very serious for serious purposes. And therefore if there are systematic errors like here, these lines is some is missing scan line scenario, then by employing digital image processing it is easy to remove systematic errors. And one of the systematic errors is missing scan line. An example is here shown that those have been removed. But of course the data which is lost cannot be recovered on the surface of the earth by any processing tools, but through some interpolation of nearby pixels we can improve so that the visualization of that image becomes more comfortable. So this is, in that case, is the third step in digital image processing, which is the image restoration. The next one is morphological processing. Here we employ different types of spatial filters, maybe spatial filters or maybe frequency based filters. Again the main purpose is to improve the quality of image or hide certain frequency features or enhance certain frequency features, and so that morphological processing is employed. And this is the input image on the left side, and after this filtering or morphological processing, a lot of the detail means this is basically edge enhancement, and so the details which were present on the edges means here of two objects, like here water body and land part, and this contact between water body and land part has been highlighted through the filtering techniques. Rest of the details have disappeared from the image. So it's from a continuous image it has become more or less a binary line image. But for certain applications this might be very useful, and therefore people go for such kind of morphological processing. The next in this digital image processing step is the segmentation, where, because image is a continuous data and the digital values are also continuous. This is, since if I take example, if it is a 24 bits image, means the 3 channels of 8 bit each, the resultant image is 24 bits, and lot of details are available even within the vegetation. But I know all this vegetation, and I want to use this image to prepare a classified image. That means I have to segment it, and for that all built up land has been given a red color, their boundaries have been restored through filtering and other things, and also like a green color for the healthy vegetation, some are built up land some other color, and likewise the legend is given here, and I can segment a continuous image into say just 4 or 5 classes, or maybe land use, land cover, and so on. So this is another step. All these steps we will be seeing in subsequent lectures in much detail, but just I am giving you the glimpse of what digital image processing can do. And then next is the object recognition, which is little advanced technique that we would like to identify a pattern or an object using our digital image processing techniques, implying fast computing and other things. Like here, and a building is there, the shade which has got the shade, and by putting certain conditions it can be further marked, and then finally rest of the details might be removed from here, and only the building is detected. So that object has been recognized here, that it is a building with shades, as a roof as having shade. And then next step, or in that case you can call as a last step in conventional digital image processing, is the representation and description. And that means that now, like here, a lot of details are here. Now I want to represent this image only through some points or some pixels. Likewise here, maybe from raster to vector conversion and so on. Those things can also be done through digital image processing, as in two examples are shown here. There is another, as I have said, that it not directly connected. At any stage one can employ image compression and then color image processing. Generally it is in the start, and generally this is in the at the time of storing the image, so that it occupy less space on hard disk. Image compression is employed, but nowadays there are image compression techniques which initially you can compress the images, and many processing steps can be taken without decompressing it. So that is why image compression is very important. One of the most common thing which we nowadays use is these zip programs by which we compress, but in these zip programs everything is compressed, whether it's a text file or your image file or audio file, that kind of thing. But here we will be discussing in image compression techniques mainly the satellite images or raster data, how it can be compressed and the size can be reduced. And as you know, there are two major types of compression techniques, and one is non-destructive, another one is destructive, means you cannot go back to the original, that is the destructive. So those kind of constraints are there which we will discuss in this one, in the image compression. Now the last in this series is that is color image processing. This figure has already appeared in previous lectures, that because you know, the black and white image is not as good or soothing to the eyes as to color image, and therefore once we are having multispectral data, then we always prefer to go for colored images, because our interpretations becomes much easier. We can draw the good inferences out of, but if it is simple black and white, then it is not possible. And many sensors are having panchromatic cameras or sensor on board, and they are broadband. So though for certain purposes they might be useful, but for certain purposes they are not useful, because ultimately the image which you get is in black and white. However, with some employing certain image processing techniques like image fusion, you can exploit the best quality of your panchromatic images, which generally are in high resolution, and best quality of your multispectral images which are having your colors in it, and then you can fuse these two images to get a new output. So that technique, those techniques are also here we will be discussing in this course. So this brings to the end of this different steps of digital image processing which we will be employing in this course. Thank you very much.